Redox reactions are fucking hard, but by the end of this video series, you'll be a pro at balancing redox equations. You see, there are a set of steps or rules that we can follow. And that means we can break learning down into manageable pieces. So each one of these pieces here, each step, has a guide, practice problems and solutions, and videos over on my website at breslin.org/redox. You should go there now. In this video, we're going to look at oxidation numbers. Then we're going to talk about how we determine what's been reduced and what's been oxidized. Let's get started. Understand that oxidation numbers are not the same as ionic charge. Sometimes they overlap, like down here. The sulfide ion, its ionic charge, always 2-. And in this case, -2 oxidation number. But here, in SO3, the sulfur has an oxidation number of +6. And we don't really talk about ionic charge since it's covalent. We'll talk more about oxidation and ionic charge later. So let's check your understanding of how we assign oxidation numbers. Like most things in redox, we have a set of rules we can follow and then assign our oxidation numbers. Pause, give this a try. Assign oxidation numbers to each element here in each substance. If you didn't get 5 out of 5, go over to my website, look at the guide on oxidation numbers, watch the video and do some practice. You need to be able to assign oxidation numbers so you can see what's reduced and what's oxidized in our redox reactions. It also tells us whether we have a redox reaction in the first place. So take a look at these 3 reactions here. The oxidation numbers are on top, and determine which one of these is a redox reaction. In this first one, each atom has the same oxidation numbers in the reactants and products. It's not a redox. Even though we have ionic charge here, doesn't mean it's going to be redox necessarily. In the second one, we go from 0 to +1. So that changed. And the chlorine went from 0 to -1. That changed. That's our redox reaction. In the last one, no change. And for double displacement reactions like this, they aren't redox. So not all reactions are redox reactions. As you learn to balance these redox equations, realize that this stuff's kind of hard. It's going to take a little more effort and time than other chemistry topics, but it's valuable. Things like batteries, combustion, photosynthesis, respiration, all those things involve redox reactions. So it's important for you to know, and you can do it. It's just going to take a little more effort. Let's look at a simple redox reaction here. In this case, ionic charge is the same as oxidation numbers. Let me write the oxidation numbers above. And you may have noticed for oxidation, the plus goes in front. For ionic charge, it goes after, just the way we do it. So the iron starts out as 0 and it goes over to +2. When that number increases, the oxidation number increases, it's oxidation. We say the iron's been oxidized. The copper goes from +2 to 0. The number got smaller. We say it's been reduced. To become +2, the iron lost electrons. Those electrons, they were gained by the copper. Think of it this way. Because this 2+, we added negative electrons, the number got smaller. It went to 0. That's reduction. Iron, it lost electrons. It lost negative charges. That made it more positive. So pause, see if you can figure out what's oxidized and reduced in this reaction. So the oxidation number for the copper got smaller, it was reduced. That means the aluminum was oxidized. The copper gained electrons. The aluminum, it lost electrons. And here's an easy way to remember that. Leo the lion goes grr. This is Leo. So when we lose electrons, we call that oxidation. When we gain electrons, it's reduction. Great way to remember it, and you'll need to know this. So let's do some more. As with all things in chemistry, it does get a little bit harder. So pause and identify what's oxidized, what's reduced, and what loses and what gains electrons. +7 to +2, that number got smaller. That's reduced. And for it to be reduced, we had to add negative charges. We added electrons. So here, we gain electrons. Down here, the number got larger. 0 is larger than -1. That's oxidized. And electrons were lost. Remember Leo, losing electrons is oxidation. Gaining electrons is reduction. Leo the lion goes grrr. Let's do another one. Pause and give this one a try. What's oxidized, what's reduced, what lost, and what gained electrons. Note here that the atoms aren't balanced, 2 chromiums and 1, and that we have oxygen on this side and not on this side. We'll fix that later when we balance half reactions. But for now, the chromium's reduced, so it gained electrons. The iron was oxidized, it lost electrons. One last one. Give this one a try. So gaining electrons is reduction, and losing electrons is oxidation there. So now with oxidation numbers, you can figure out what's been oxidized, reduced, what's lost electrons, and what's gained electrons. And remember, when we're doing redox, we balance atoms and electrons. That'll be important in the next video when we write half reactions. If you'd like to help support my work, there's lots of ways you can do that, not just financially. Head over to breslin.org/redox there, and you'll see some ways that you can do that. This is Dr. B, and thanks for watching.